We're located at Starseed Gardens Nursery in Byron. I'm Paul Taylor. I'm actually a physicist, in fact an astrophysicist. I was designing payloads for the space shuttle in the United States where I worked for 40 years.
I ran a renewable energy company, so over the years we got more and more interested in biochar as it became obvious about climate change and needing to get CO2 out of the atmosphere.
But I quickly realized that we were at the point now where we didn't only need to stop emissions, we really need to look after our land. And we needed to strengthen it so it would not start to release carbon, and we need to pull the carbon back down into the soils. And that's where I learned about biochar a few years ago.
I was mainly focused on getting commercial production of biochar, and then I retired from the company. I'd sold it to some Americans, and then I became more involved with education and promotion. So Paul and I decided to work together on this.
And we're teaching people how to make biochar in mixtures, and we've done a lot of work already yesterday and a lot of instruction, and now we're at the point where we're making special ovens, advancements on previous designs to make biochar. But it's backyard scale, small property scale, and so on.
It's just got so many advantages. It helps farm without chemical fertilizers, it helps lock up carbon, it brings people together because you need a community biochar kiln and stuff like that. And so yeah, it's just got so many good things going for it.
And what biochar is about is that you take waste material, and waste material is all over the place, waste biomass, waste stuff that was once living. Lots of agricultural residues, for example, in the sugar industry we burn the stuff. So take that material and put it through a process not of combustion but of pyrolysis. And pyrolysis means to break down under heat. That's a piece of bamboo that has been carbonized, and if I squeezed that it would just crush up.
And then we're going to put straw and very fine bits of bamboo so that it's going to provide enough heat to get this to pyrolyze.
And then you have a solid product coming out, which is just charcoal. It's char. It's the same stuff, more or less, that you would burn in your barbecue, but we don't want to burn it. We want to crush it up, we want to condition it and put it into the soil. Charcoal is long-lasting. We all know you can dig up an old campfire and you can carbon date, you might have 10,000-year-old charcoal in there. So it lasts a long time in the soil. Because it lasts so long, one of the things it's done is it's sequestered or captured carbon into the soil. The second thing it does is it kind of acts like a coral reef for microorganisms. It's like a barrier reef in terms of diversity of microorganisms on a miniature scale in the soil. And the microorganisms are fundamental to most plants for their health and their nutritional quality and their growth.
I've been working with biochar for a few years now, and soil science for many years, and have set up this place as a garden specifically to act as a showcase for a lot of these ancient wisdom but some of the newer technologies combined to enable people to grow plants in a way that's in harmony with nature.
I have a family in India, my son's Indian, and they're expressing how they can't afford their stables anymore and expressing about the cost of cooking, and there's no wood left in India to go and, find the wood to cook on. So I can see it's getting harder and harder for just average basic needs. So biochar, I think, could be a fantastic way of very poor people being able to cook on.
I don't like to see the waste in the biochar, so the waste heat. So my whole focus has been on cooking to make my biochar. So my cholesterol's going up. My recipe count's getting good. We did pizzas last week. And this was my little pizza oven invention to get the fire to go through the Weber and out the other side. Still all experimental to try and generate as much heat as possible.
And the Japanese make all sorts of sculpture material out of this. They make material to put in their mattresses. They make material to condition the humidity in their home. So they actually make 40,000 tonnes of this a year.
The art of biochar manufacture and utilisation is most advanced in Japan and in some areas in China. China produces well over 100,000 tonnes a year of biochar, but they've also developed systems where they take the smoke out of the pyrolysis reactor and condense it out and use it as a wood vinegar, which is a biopesticide. They use it for medicinal purposes, so there's a long tradition. I was just in Nepal and doing a consultancy job for the Asian Development Bank, and we were going around to villages and talking to people about biochar. Anyway, we went to one village up in the mountains. It was a Tamang ethnic group, and lo and behold, they were making biochar, and they've been doing it for centuries. And basically they said if they don't make biochar, then they can't grow their crops.
So I think it's a really great, simple technology, and yeah, it's also, you know, sequestering carbon into the soil, so it's like really quite a good environmental thing. It's taking carbon from the atmosphere and putting it into the soil.
The future is going to be all about biomass and biomass energy as opposed to fossil fuel energy. Fossil fuel energy is on the way down, biomass energy is on the way up.
Take waste material, turn it into a valuable end product, put it into the soil, grow better food, and help the climate as well.
Material in there. And a lot less.
High temperature, low temperature biochars, high mineral ash biochars, low mineral ash biochars.